This is chapter 11, topic 11, qualitative chemical analysis. How can you verify? This is all the reactions that if you open my notes, the drive, they're all there. Yani it's down here. As you know, it's not in the solution. It's in the solutions. Over here. No, here. This is all of them. Well, they're also in the notes that I have posted in my drive and in the notes that are posted for topic 11 and chapter 2. Yani you can find this table, it should be memorized from A to Z. Okay. Let me go back here. Let's try and finish this recording in under 45 minutes. How can you verify the presence of H plus in a solution using pH? If you have pH, if there's high H plus, then obviously the pH will be less than 7, right? So if it's less than 7, then solution has high H plus. How can you verify the presence of H plus using the materials listed below? Write the net ionic. Let's forget about the net ionic and first let's focus on what actually happens. Okay, expected observation. Sodium carbonate. You know, to test for carbonate ions, you add an acid which has H plus in it. And when you add H plus to a carbonate, you get CO2 gas and you also get water. Okay, so the expected observation would be effervescence. If they mentioned that the gas was tested, then you say that it turns lime water milky. Or you can say it releases a gas that turns lime water milky. But you don't say that the observation you saw was lime water turned milky because you didn't say you added lime water. The marking scheme is. This is also the net ionic because this is aqueous. This is aqueous. So basically, this turned from aqueous to liquid, so you write it. And this turned from aqueous to gas, you write it. You should memorize this, okay? This is the net ionic. Okay? A piece of magnesium. Then they said magnesium ribbon. A piece of magnesium ribbon? So with magnesium ribbon, you should know that when you add H plus to magnesium ribbon, you get metal. Remember, guys, remember from our previous chapter or our other chapters for this periodic, especially in chapter 3, acid plus metal gets you salt plus H2 gas. The acid is composed of the cation of H plus, and I don't know, it's any anion, right? That's an acid. It's H something, right? The metal is just a metal. The salt comes from the anion and the metal, but the hydrogen gas comes from the H plus. So if you removed, like if you just kept, like instead of saying acid, if you just used H plus, we're not gonna have a salt, but what we're gonna have, the acid H plus metal, what will give you? Hydrogen gas. That's just the explanation, but you can just memorize. Let's plan as the magnesium ribbon, it will produce hydrogen gas. And how can you test that there's hydrogen? How do you test for hydrogen gas? If you light it up and approach, if you light it up, it will produce a pop sound up. Pop, 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 pop. How are the ions of lithium, sodium, potassium identified? You know, you can use the flame test, right? I don't think did they actually give the colors. Yeah, lithium gives you crimson red flame, sodium gives you a yellow flame, and potassium gives you a violet, violet flame, or you could say lilac. Use the colorless. Give the blue or colorless flame a distinguished color. Okay. A flame test is conducted on calcium chloride. What color will the flame have? Calcium gives you a brick red flame. How can you test for calcium ion? Yeah, how can you test for calcium ion using a concentration solution of sodium hydroxide? Write the net ion equation for the reaction. Report the expected observation. Okay, so for this one, honestly, I don't understand it, but just memorize it. Okay, if you add it to a base, okay, apparently it's gonna make calcium hydroxide, which is slightly soluble, so it makes a white precipitate. Oh, I just understood it. Calzone. And you have NaOH, NH3. If you guys remember this table, calcium hydroxide, calcium when you add to NaOH, these all form white precipitate. They all form white precipitate. But when with NaOH, it forms insoluble, and it doesn't form anything with NH3, right? And then with aluminium, it forms a precipitate that is soluble in excess NaOH, but it's insoluble in NH3. And then for zinc, it's soluble in both. Yeah, I forgot about this table. Uh, Question 2. How can you test for the following ions using sodium hydroxide and ammonium solutions? Write the net ionic equation for the reaction between the ions tested and the alkali used and report any expected observations. Here we should have written the net ionic. It was Ca2 plus 2OH minus to produce CaOH2. I think this is double arrow. It is a double arrow. No, it's not. Okay. Okay, guys, since it's insoluble, so I have to say it's solid, huh? The time is actually 4:56 right now, guys. That's uh anyways. Uh you get this. This is the net ionic. Okay, so remember we said for aluminium, calzone, and you have NaOH and NH3. Let's skip to aluminium. We said it's soluble, insoluble, and then soluble, soluble. Okay, so how can you test with following ions using sodium hydroxide? Write the net ionic equation. Okay, let's start with aluminium. Okay, what is the expected observation? White precipitate formed that doesn't, I ain't writing all that doesn't dissolve, that dissolves in excess NaOH but doesn't dissolve in excess NH3. So you can say the net ionic will be, and you're gonna get AlOH3 because you crisscross, so that means you have to balance and put a 3 here. Okay, this is just هيدا. Okay, and then for zinc, it's a white precipitate form that dissolves in excess NaOH and excess NH3, and the net ionic will be this. Because you crisscross, so you have to put a 2 here. Okay, that's it. White precipitate form that dissolves in both. Where are we? And if you drop, it produces a white precipitate, and that is soluble in excess, insoluble in NH3. Okay, we wrote all of this. Oh, come on, you have to put state symbols, guys. Solid, solid, aqueous, 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 aqueous. Okay, question 3. How can you test for the following ions using sodium hydroxide solution? Write the net ionic equation and report expected observation. Okay, using NaOH. If you add Fe2 plus to NaOH, you know that you get a green precipitate, right? But you have to know that here it's Fe2 plus. 2 plus and 3 plus are different because 2 plus will give you a dirty green precipitate, but Fe3 plus will give you a red brown precipitate, right? طيب, how about Cu2 plus? It will give you a blue precipitate, right? Pale blue precipitate. And then for chromium, it will give you a green precipitate. But how can you distinguish between Fe and Cr? Is that Cr dissolves in excess NaOH, but Fe2 plus does not. Okay. How can you test for copper ions using ammonia solution? Report expected observations. No equations are necessary. Obviously, copper ions will form a deep blue solution, but in excess, no, will form a blue solution. Will form a blue solution with ammonia, but when added to excess ammonia, that precipitate, when added to drops of ammonia, it's gonna form a blue precipitate that when added to excess ammonia will dissolve, creating a deep blue solution. Yeah, so adding few drops, when you add a few drops to copper, you're gonna get a light blue precipitate, and that precipitate dissolves in excess ammonia to give a deep blue solution. I got this wrong in the written part in the first periodic, so yeah, I remember it for that reason. How can you identify ammonium ions using solution of sodium hydroxide? You know that when you add ammonium ions to sodium hydroxide, you're gonna get ammonia gas and water. Write the net ionic equation for the reaction, report any expected observation. The net ionic will be this. Plus OH minus to produce NH3 and water. Okay, and this is gas, aqueous, aqueous. طيب, any expected observation would be release of a gas that has a pungent smelling gas that turns damp red litmus paper to blue. Okay. Anyway, H warming produce. Yeah, you have to warm it. Produce ammonia gas. The gas can be detected by its pungent smell or its action on a moist red litmus paper. It turns litmus paper blue. Okay. Yeah. How can you verify the presence of OH ions using a pH meter? Obviously, if the pH is greater than 7, then there's a high concentration of OH. How can you test for the following ions using silver nitrate solution? Write the net ionic equation. If you add silver nitrate, AgNO3, to Cl minus, you're going to get a white precipitate. To Br minus, you're going to get a creamy precipitate. And for I minus, you're going to get a yellow precipitate. Remember, I love you, yellow. I love yellow. Iodine loves yellow. Okay? The net ionic equations are gonna be Ag plus Cl minus aqueous to produce AgCl solid, and here it's Ag plus Br minus aqueous to produce AgBr solid, and this is gonna be Ag plus I minus to produce AgI solid aqueous. How can you test for the following solutions using hydrochloric acid solution and using an acid? Write the net ionic. If you add an acid to carbonate, H plus CO3 2 minus, what do you get? Acid plus carbonate gets you always carbon dioxide gas and water liquid. Aqueous gas liquid. HCO3 so apparently HCO3 behaves like carbonate, so it's just gonna be the same thing. Okay. Shout out to Laith Aloni for helping me out with this one. I didn't know it. He's very smart in chemistry, and anytime I need the help, yeah, like he always helps me out with these questions. He's in Sharjah, by the way, for anyone who's so Laith Nasr Aloni, that's his name, guys. If you ever need help, just hit him up. He's always there to help you in chemistry. Anyway, H plus HCO3 minus behaves in the same way, same reaction. So you get CO2 gas plus H2O liquid. It's important to note because he said expected observation. You say effervescence and produces a gas that turns lime water milky. You have to say this. SO3 to minus, when you add an acid to SO3 to minus, it's always going to be. I should put a I should have put a plot. I should have put a plus here for H. So H plus SO3 to minus behaves like CO3 to minus. So it's going to be SO2 gas and water. How can you test for SO4 to minus? Write the net ionic equation for the reaction and report the expected observation. To test for SO4 to minus, you add barium. And when you add barium to SO4 to minus, what do you get? You get BaSO4. So it's an insoluble white precipitate, okay? But it dissolves in acid, okay? So write the net ionic equation for the reaction and report expected observations. So you'd say insoluble precipitate. No, it's insoluble. It's insoluble. Oh my god. Add a few drops of. You have to say it's acidified. Yes, it's very important. You can't just say barium. The net ionic is this, okay? But you can't just say barium. You have to say acidified barium, okay? Any barium. So you could say barium chloride or barium nitrate. Anything, adi, easy peasy, and you get white precipitate, okay? Write the net ionic equation that for the reaction that takes place when a few drops of sodium sulfide are added to a solution of lead nitrate, PbNO3. What observations are expected in this case? So we didn't take this, but like apparently when you add Pb ions to sulfur, you get a black precipitate. You just get a black precipitate, guys. Remember that Pb is black, okay? So anytime you have sulfur to test it, you add Pb. Just like Hussam, guys, you're gonna get a black precipitate, okay? Okay, خلاص, just next question. Describe how each of the following gases are tested. Oh my god. I'm just gonna show you the solution. I ain't bothered. Okay, you need a lit splint for hydrogen because the lit splint explodes, right? It will explode. Hydrogen will explode. And then oxygen will give you a glowing splint because it lights on fire, right? It relights. Glowing splint always relights. Yeah. NH3 ammonia gas. What do you do with it? Damp red litmus paper? What happens to it? Turns blue. Carbon dioxide gas. It turns lime water to milky. Right. Pass the gas through lime water for a short time. Lime water turns cloudy. What milky? You. Oh, that's a weird equation. Ca plus OH plus CO2. CaCO3 plus H2. Oh shit. So you should know. You should don't. The equation. I think it's useless. Yani. But you should know that for a short time it will turn milky, but if it's a long time, it's just gonna become clear again. Chlorine, damp litmus paper, it bleaches it, right? Sulfur dioxide, it reduces the color of acidified potassium marginate from purple to colors. Okay. Cobalt chloride is. Okay, yeah, incense. Question 9. Identify the unknown gases. Yellow, green gas, chlorine. Colorless, odorless gas that lights a glowing flint, lights it, oxygen. Colorless, odor gas that pops, hydrogen. Colorless gas with a pungent smell that turns moist litmus paper blue, obviously pungent smell, ammonia. A colorless gas turns lime water milky, carbon dioxide. A colorless gas decolorizes a purple acidified aqueous potassium marginate into colorless. From purple to colorless, that is SO2 sulfur dioxide. How can you test? Yeah, just look at the answers, huh? How can you test for the presence of water in a sample of colorless liquid? Write an equation. I don't think we have this topic in it. Oh shit. Add a few drops of anhydrous copper sulfate. Yeah, this came in our written. Okay. So when you so how do you test for water? You add anhydrous copper sulfate, okay? And anhydrous copper sulfate in the presence of water, it changes from white or colorless to blue. Because water is colorless, changes to blue. So it's actually here in the notes, guys. Anhydrous copper sulfate. This text should be swapped with this text. So anhydrous copper sulfate turns white anhydrous copper sulfate to blue. So from white to blue. Okay. And then anhydrous cobalt chloride actually turns blue cobalt chloride pink. So cobalt turns from blue to pink. In case they may ask this in your written or anything. I wish I did course vision last exam. But yalla. How can you distinguish between hexane? Okay, we do not have this. We do not have this. Yeah, okay. If you want to memorize, you're more than welcome. But in hexane, the yellow-orange color of bromine rapidly disappears. No, as in hexene, it rapidly disappears, but it persists in hexane. You can memorize this, and you're more than welcome. I don't care. But, I am memorizing this, bro. Okay. As soon as asked to identify two salts T and W, the observation. Okay. Observation 1: solution of T forms a white precipitate with aqueous sodium hydroxide, and the precipitate does not dissolve upon adding excess sodium hydroxide. What's the only one that doesn't dissolve in excess sodium hydroxide? Ca2 plus. So the cation is Ca2 plus. Observation 2: solution 2 forms a yellow precipitate with AgNO3, silver nitrate, AgNO3. Which one's yellow? Iodine loves yellow, so I minus. Deduce the formula of salt T, crisscross, you get CaI2. The student noted that the following observation while testing salt W. Salt W gives a red color in a flame test, so it's lithium. And solution W releases a gas that turns blue wetness litmus paper blue upon addition of dilute hydrochloric acid and gentle heating. Blue litmus red upon adding an acid. It could be any of. It can either be CO3 2 minus or SO3 2 minus. I think it's gonna be SO3 2 minus. Because look, CO3 2 minus releases carbon dioxide gas. SO3 2 minus releases SO2 gas, and these are both acidic gases. I'm not sure. With the cation, okay, it's easy. It's Li plus. The anion, I'm still redundant. I don't know which one. The formula. Okay, describe how a flame test is done. Flame test is done. You dip a wire in the solution, platinum wire in the solution, and then place it over a blue Bunsen burner or colorless Bunsen burner. So let's see here. So they took sulfite. Okay, okay. You can take sulfite. Since they took sulfite in the course of vision, in the exam you take sulfite. Okay, don't take CO3. Okay, so a kid's gonna be Li2 SO3 if you crisscross, 2 goes to Li. Okay, and the flame test platinum wire is dipped in concentrated. You dip it in acid, and then holding it in a hot flame. This is repeated until the wire does not give any color in the flame. Okay, you can memorize this. So أول شيء for flame tests, you take your wire, you dip it in acid, because hydrochloric acid gives you a colorless flame. You keep on dipping it until you get a colorless flame over the Bunsen burner. When you get a colorless flame, then you dip it into now the acid you're testing or whatever you're testing, and then you put it back onto the flame, and the color you get is the color of the sample you're testing. A student was analyzing two solids A and B. Solid A is zinc iodide with solid B is unknown. Test on solid A. Solid A was dissolved in water and the resulting solution was divided into 3 test tubes in equal portions. First portions, a drop of aqueous sodium hydroxide was added. Okay. We have zinc iodide. Sodium hydroxide with zinc. What do you get? You get white precipitate is formed. Because they said few drops. We said it dissolves when it's in excess. Here they said excess. What do you say? White precipitate dissolves. A few drops of aqueous ammonia were added. This is test A. Yeah. Ammonia. When you add it to zinc, what's going to happen to drops? Again, white precipitate is formed. And when you add it in excess, what's going to happen? Again, it's going to dissolve. Okay. Dilute nitric acid and aqueous silver nitrate were added to the solution. So we added. So when you're adding AgNO3, because silver nitrate is AgNO3, we have what here? It's acidified, because that's why they said nitric acid, because it's supposed to be acidified. نحن we have iodide, and what happens when you add I minus ions to AgNO3? Yellow precipitate is formed. Okay, so part A. White precipitate is formed that dissolves in excess. White precipitate is formed that dissolves in excess. You have to say giving colorless solution. Say giving colorless solution. And yellow precipitate is formed. Part B. After dissolving solid B in water, the following observations were recorded while testing solution B. Dilute solution of sodium hydroxide was added. So they added sodium hydroxide. They got pale blue precipitate. So immediately you know that it's what ion? Cu2 plus. Aluminum foil. Aluminium. بسرعة. ما تضيع وقت. You see aluminium, NO3 minus. Very, very easy. So Cu 2 plus and NO3 minus. What do you get crisscross? You get Cu, NO3, 2. Okay. A student, is this our last question? Yes, it is. Under half an hour. Beautiful. A student analyzed soluble carbonate salt R. Okay. So it's a carbonate salt. No observations were recorded, and when the carbonate R was slightly heated in the test tube. What does this indicate about salt R? That it doesn't contain water, huh? Yeah. If you heat a solid or a salt or whatever and nothing happens, that means there's no water. But if you heat it and like you see bubbles, or like if you heat it and you see like water vapor releasing, that means the solid obviously contained water. So it was heated, nothing happened, it does not contain water. Salt R was dissolved in water and divided equally into 4 test tubes. The following tests were conducted. Complete the observations for each of the following tests. In test 1, a small amount of acid was added to the first test tube. So remember, we have carbonate. What happens when you add acid to a carbonate? It produces a gas, whatever. Okay. Then test 2, the gas released was bubbled in lime water solution. What is the observation? Akid, if you put the gas, wait, what am I saying? The gas released from hydrochloric acid plus carbonate, remember you have CO3 2 minus, carbonate plus the acid H plus gets you carbon dioxide gas and water, right? طيب, you get carbon dioxide gas. What happens if you put carbon dioxide gas into lime water? You're gonna get milky white. Lime water turns milky white, and I don't like it. What's the gas released? Carbon dioxide. Okay. 2 more tests were conducted and the following observations were recorded. You have test 3. To a new test tube, they added sodium hydroxide, so they added the base. The mixture was then warmed carefully. They got effervescence, pungent gas given off, gas turned litmus paper blue. Identify the ion present in the solution from the observation of test 3. So, it was carbonate, right? But we don't know what the cation is. Carbonate we know is an anion because it's CO3 2 minus. So there's a cation. What is it? Let's see. Pungent gas was given on. So what is that? That's ammonia, right? And to get ammonia, did they mention anything about aluminium and heating it? They didn't mention anything about aluminium, right? So that means the cation used here is NH4 plus. So also it can't be nitrate ion because NO3 minus. I already have an anion here. CO3 is a minus. I can't have 2 minuses, right? I can't have 2 anions. Okay? طيب. So the ion present is going to be NH4. plus. Why did the damp litmus turn blue? Because NH3 turns damp red litmus. NH3 is basic. Just say it's basic, صح? Gas is basic, yeah. Identify the gas released ammonia. Okay. Write the chemical formula for salt R. Now that we know it's NH4 and we have CO3 2 minus, so we have NH4 plus. And the question they had is carbonate, so CO3 2 minus. If you crisscross, what are you going to get? NH4 2 CO3. Why is it necessary to warm carefully? Because, well, why is it necessary? Okay, so NH4 2 CO3. Okay, sodium hydroxide is hazardous. Uh, yeah. So you say yeah, it's a base, so you don't want to touch you. So just say if you need to warm carefully so that the sodium hydroxide doesn't spill or spit or whatever. Blow. Again, guys, credits to Laith Nasser Alauni for helping me with that one. I didn't know it, I didn't really understand it, but he helped me out with that. Thank you so much, guys, for watching topic 11, and good luck.